Hello everyone. Today we're going to take a look at the January 2021 past paper. First fractions question number 1A. Here we see that we have two operations, an addition and a subtraction operation. This can be done in any order, so let's just proceed. So we'll first convert to improper fractions. So that's 7/7 plus 4 is 11 over 7 plus 2 over 3 minus 11 over 6. So we simplify further. The LCM would be 42. So we'd have 66 plus 28 minus 77. And this works out to be 17 over 42. All right, so let's move on to the second part of this question. So we are to find the cube root of 27 and divide that by 9 squared. So the cube root of 27 we know to be 3 divided by 9 squared. That's 9 by 9. So 3 and 3 goes 1, 3. So we have 1 over 27. Part 1b of the question says we have a cardboard which is 485 times 10 to the minus 2 millimeters thick. And we are going to stack 75 of them together. So we'll have 75 of these cardboard with thickness 485 times 10 to the minus 2. Now let us just recognize that 485 times 10 to the minus 2 is really equal to 4.85 millimeters. So 75 of these would give 75 times 4.85, and that is equal to 363.75 millimeters. So if we put this value here, so the two significant figures, we would look at the third number. It is less than 5, so we leave as 360 millimeters. To one decimal place, that is easily seen as we have two decimal places here. This is 5, therefore we could increase this one by 1. So we have 363.8 millimeters. And finally, in standard form, we simply write as 3.6375, and we had shifted two decimal places, so we multiply by 10 squared. In 1C, we are going to convert ECD dollars to Mexican dollars. And in this case, we have 630 ECD dollars, and that we know converts to 4,500 Mexican dollars. So what is the value of 1 ECD? We simply divide 4,500 by 630, and that works out to be 7.14285. Question number 2. We are to factorize 12n squared minus 4mn, and if we notice that the only thing common to both, well, we could take a 4 out and we could take an n, and we'll be left with 3n minus m. Okay, so here we have a simple equation to solve. That's question number 2b. So let's take a common denominator in the first instance, which would be 1 minus x. Then 1 minus x into itself is equal to 1. So we have x minus 4x into 1 minus x. That is equal to 0. We can now multiply both sides by 1 minus x. We get x minus 4x plus 4x squared, and that is equal to 0. So we could collect these two terms. We have minus 3x plus 4x squared is equal to 0. We could take x as a factor, and we have x into minus 3 plus 4x, that's equal to 0. So we have two factors that are equal to 0. So we say either x is equal to 0 or negative 3 plus 4x is equal to 0, which would give 4x is equal to 3 or x is equal to 3 over 4. So the two answers are 0 and 3 over 4. Let's move on to question 2c. Here we have a problem involving transposition where we need to change the subject to v. So what is our first step? First, we get rid of this square root sign by squaring both sides. So we have p squared is equal to 5 plus vt. And then we simply take the 5 across, and therefore p squared minus 5 all over t is equal to v. This would be our answer. We could replace v is equal to p squared minus 5 all over t. Let's move on to question 2D. So here we are told that the distance needed by a car to stop is directly proportional to the square of the speed. So we have established a relationship here. So we could write as d is proportional to speed squared, where I use d and s to represent speed and distance. So we are also told that a car traveling at 70 kilometers per hour requires 40 meters to stop. So let's first of all form an equation here. So we can write d, replace the proportionality sign with an equal sign and a constant. So d then is equal to k times s squared, where k is a constant. This gives d over s squared is equal to a constant. This, of course, implies that d1 over s1 squared is equal to d2 over s2 all squared, where d1 and d2 refer to different distances and different speeds. So in this case, we're given that d1 is equal to 40 meters when the speed s1 is equal to 70 kilometers per hour. Therefore, if we're told that the car is traveling at a speed of 80 kilometers per hour, what distance would be required for that car to brake? So here we can use our relationship that we just established, our formula, and we can change the subject for d2, which is our unknown. So in this case, if we transpose here for d2, we can write as d2 is equal to d1 over s1 squared times s2 squared, or simply d1 times s2 over s1 all squared. This is the same as this. Notice that these two are the same. So we could now solve as 40 times 80 over 70 all squared, and that is going to give 52.2 meters. In question 3a, we're given a diagram. Here we have two objects, P and Q, and we're asked to make a statement about these two objects. And the choices are they opposite? Do they represent a reflection? Are they congruent? Or does this represent a translation? So from those options, we can see that these two are simply congruent. What does congruent mean? A, we have corresponding sides are equal, and 2, the corresponding angles are also equal. So that describes the properties of congruent objects. Let's move on to question 3b. Here we're given a simple pentagon, and we're told some things about the pentagon. We're told that A, sides V, W, and Y, X are parallel. That is the same for W, X, and ZY. Those are also parallel. So we're asked to determine A, this angle. Let's call this angle here at X, and this at V. So we're asked to determine these two angles. These are the two unknown angles. So the first thing we want to do is we want to look at the fact that these two lines are parallel. We could simply extend this line and recognize easily that based on corresponding angles, this angle is equal to 114 degrees. So this would be 114 degrees. This line is parallel to this line, so this line is a transversal. Clearly, these represent corresponding angles, and therefore this would be the supplementary angle, because angles on a straight line is 180, so this would work out to be 66 degrees. If you also notice that if this line is also parallel to this line, then line WX, let's extend that a bit so we could see, it also represents a transversal where this angle is equal to this angle, and if you notice this angle 114 is equal to this angle at W, because this would be an alternate angle. Here we have a Z at this angle here, so this angle would also be equal to 114 degrees. That is because these two lines are parallel. Therefore, this line represents a transversal. Finally, we have only one unknown in a pentagon. The sum of the interior angles of a pentagon is equal to, so let's write total interior angle, and that's equal to 2n minus 4 times 90 degrees, also referred to as 2n minus 4 right angles. Since n for a pentagon is equal to 5, we have that's equal to 2 times 5 minus 4, and multiply all of that by 90 degrees. So we have 10 minus 4 times 90 degrees, or 6 times 90 degrees, which is equal to 540 degrees, is the total interior angle of the pentagon. And therefore, we merely need to subtract the remaining angles to get angle at V. So we can write as angle at V is equal to 540 degrees, subtract all the other angles. Let's just write them down here. And that works out to be 148 degrees. So this is your angle here, 148 degrees. And your angle here is 66 degrees. Okay, so here we have a transformation problem number 3C. So let's just take a look at it and see what it is we're being asked to do. So we have the letter A, and we're told that the center of enlargement is located at 6, 6. So let's write that down here. So this is our center of enlargement at 6, 6. So we want to now enlarge this object by a factor of 2. So our scale factor is 2. So how do we go about doing this? Well, the first thing we do is we recognize that from the center of enlargement to any vertex, we know that the enlarged image must be a part of a line that connects those two. So let's just project a line from the center of enlargement and see where that takes us. So let's just draw this line. Now it may be useful to give our vertices names so we can refer to them. So let's call this vertex P. We can call this vertex Q. And we could call this one R. These are just names that we're going to assign for convenience because it's going to help us later on. So we know that P prime must lie along this green line, and we're going to determine where that is. Now, since the scale factor is 2, we know that P prime is twice the distance C to P. So C to P prime is twice the distance C, this is our point C, to P. So we could simply use our ruler and measure this distance, or we could just recognize that it is 2 diagonals away. P prime would be twice the distance from the center of enlargement as P. Similarly for R, similarly for Q, we simply need to draw lines between the center of enlargement and each vertex and simply double the distance to find the corresponding image coordinates. So let's just do this. So once again, we note that Q and the point Q prime are related by the enlargement factor, where C to Q and C to Q prime is simply twice the distance from C to Q. So C to Q prime is twice the distance, and if you measure, that would actually end up being right here. So Q prime would be here, and of course R prime, similarly, the distance C to R, where C to R prime is twice the distance, which is actually here. And now you go ahead and connect your enlarged image. You should also note that you can get the center line for A using the same technique. You simply identify one point on this object. Let's call this T for argument's sake. And you draw a line through T from the center of enlargement to project onto the image coordinate to determine T prime. Let's do that now. Now we can complete our transformation by simply finding the point T prime. T prime would be located, use a ruler. T prime will be located right here. This is the corresponding point for T prime. So we have completed the transformation of this object, and we're shown image coordinates and the corresponding image. Finally, we're asked to translate the object by a vector -3 and 2. So the translation is equal to -3 and 2. That's our translation vector. So this is our object, and we're going to move it 3 in the negative x direction and 2 upwards. So let's count P prime. From P to P prime would be 1, 2, 3, negative x direction, and 1, 2. So this would be our point P prime. Or let's call this P double prime since we already have a prime down here. So to get R, we move 3 places to the left, 2 up. So that's 1, 2, 3, 2 up, 1, 2, and Q, 2, 3 places out, 1, 2, 3, and 2 upwards. Our image coordinate after the translation is, so this will be our point R double prime and Q double prime. So here we have a functions question where we're given that the function f of x is equal to 3 minus 2x. It is written like this, but we need to recognize from now that if we see a function written like this, where this is given using a mapping notation, these two are the same. So in this case, we're asked to find f of negative 1, which means we put negative 1 here for x. So we get f of x is equal to 3 minus 2x. Then f of negative 1 is 3 minus 2 times negative 1. That works out to be 3 plus 2, which is equal to 5. Next, we are asked to find the inverse of x, written as f to the minus 1 of x. So that's f inverse of x, and that is our unknown. So let's use a familiar technique. So if f of x is equal to 3 minus 2x, then we can say let y 3 minus 2x, and then we interchange x and y. So now we can transpose for y. So in this case, we have x minus 3 is equal to negative 2y, and therefore y is equal to x minus 3 or negative 2, which is the same as 3 minus x over positive 2. So we now replace y with f to the minus 1 of x. So this gives f to the minus 1 of x is equal to 3 minus x all over 2. Continue. Let us find a value for f squared of x. Now, note that that is not equal to 3 minus 2x all squared. That is not what that is. This means f into f. So we're going to take f of x and place it into the function f of x. So let's write if f of x is equal to 3 minus 2x. So if we are going to place this into itself, means wherever I see x, I'm going to place this back into it. So it's going to be 3 minus 2, all of this. So I'm placing f of x back into itself. So this works out to be 3 minus 6 plus 4x, or 4x minus 3. Finally, we need to find f into f inverse of negative 2. Now f into the inverse of x is equal to x. This simply means that if we apply x to a function f, the result will be f of x. Now if we apply f of x to its inverse, we will get the original value of x. This is equivalent of undoing the operation. So f inverse of minus 2 back into f is equal to minus 2. Okay, so in question 4b, we're asked to draw 3 lines. X is equal to half, y is equal to x, and x plus y is equal to 5 on the same graph. So let's proceed to do that. So x is equal to half. This is a straight line parallel to the y-axis. So this is x is equal to 1, x is equal to 2, so x is equal to half will be right here. This is a straight line parallel to the y-axis, so let's draw that line. So this is our line, x is equal to a half. Number 2, the line y is equal to x. Now by now you should be very familiar with what the line y is equal to x looks like. It is a diagonal line, and if the scale used for the x and y axis are the same, it would be exactly 45 degrees from the origin. In this case, the scale values are the same, so we know that the line y is equal to x is a diagonal line that is going to be exactly at 45 degrees here. But it is very simple for us to recognize that it starts at the origin, and we could just choose any value of x and y. So for example, we could say when x is equal to 5, if x is equal to 5, y is equal to 5, because x is equal to y. So one point on that line would be the intersection of 5 and 5. We could just connect those 2 points, and that's a very simple way of drawing this line. Identify 2 points at a reasonable distance apart and just connect those 2 points. So let's just go ahead and do that. So this represents our line, y is equal to x, and our final line, x plus y is equal to 5. So how do we determine 2 points on this line? And our strategy is similar to what we've used in the past. To draw a straight line, we need 2 points. So we're going to find 2 points reasonably separated and connect those 2 points. So let's choose the first point. Let's call this one point 1. So we choose let x to be equal to 0 and determine the value of y. So x is equal to 0 and x plus y is equal to 5. That means y is equal to 5. So the coordinates are 0, 5. Let's identify that here. X equals 0, y is equal to 5. That's right here. For point number 2, we let y be equal to 0 and determine the value of x. So if y is equal to 0, x will be equal to 5. So the second point becomes 5, 0. So notice we're choosing 2 points that lie along the axes. By setting one variable to 0, we're actually on the axis. So in this case, our second point is 5, 0, which would be here. So we now have our 2 points. We simply need to connect that line. Now we need on the grid to identify the following 3 regions. Notice what we've done so far. First, let's identify this line as the line x plus y is equal to 5. So what we're going to do now is we're going to identify 3 regions on this graph so we could shade that region. Let's just identify what the inequalities for these regions are. So the first inequality is x is greater than or equal to half. The second inequality is y is greater than or equal to x. And the third inequality is x plus y is less than or equal to 5. So let's quickly represent these inequalities in our graph. For the first one, x is greater than or equal to half. If this line represents x is equal to half, then anything greater than x is equal to half must be to the right of this line. Similarly, if y is greater than or equal to x, then we identify the line y is equal to x, and if it is greater than or equal to x, it must be above the line. We have a video lesson explaining graphing inequations, so you could take a look at that if you're having some difficulty following us here. And finally, if x plus y is less than or equal to 5, then this line represents x plus y is equal to 5. So everything below this line represents the inequality x plus y is less than or equal to 5. So it's going to be below this line. So at once we can see that we have identified that this is a closed region. All the arrows are pointing inwards. Let's call this region R. That would represent the solution to the 3 inequalities. Let's have a look at question number 5a. So here we have a case where we have 60 students who took a test, and the marks for this test is identified here. The maximum mark is given as 15. 9 students scored 14, 11 scored 13 based on the information shown in this table. So our first question is to determine the number of students who had exactly 13 correct answers. So we have 13 correct answers were given by 11 students. So we could write 11 students scored exactly 13 marks. Okay, that's one. That's number 2. So we need to know the modal number of correct answers, and that would be the number of correct answers obtained by the highest number of students. So clearly 14 students obtained 9 marks, and this is the highest number of students who scored a particular mark. So the modal number of correct answers is 9. So in part 3, we're asked to determine the median number of correct answers. Now, how do we do this? Well, the first thing we do is we order the marks from smallest to largest, and that has already been done here. Next, we add another column that we find the cumulative frequency. And once we have done this, then we note that there are 60 students. So let's write there are 60 students. And since 60 is an even number, we would need to get the mark obtained by the 30th and the 31st ranked student. So that would be the average of those two. So by creating a cumulative frequency column, we can easily identify the 30th and the 31st student. So the 30th ranked student obtained 12 marks, and all students between 30 and 40 also obtained 12 marks. The 41st student obtained 13 marks. So the 30th and 31st student both obtained 12 marks, and therefore we have an average of 12 for the 30th, 12 for the 31st. Average of that is also equal to 12. So the median mark is equal to 12. So part 4 of this question is asking us to determine the probability that a student chosen at random got at least 12 marks. But at least means 12 or more. So in this case, that would include all students who got 12 marks, plus all students who got 13 marks, plus all students who got 14 marks, and all students who got 15 marks over the total amount. So it's equal to 2 students got 12 marks, plus 11 students got 13, plus 9, plus 10 over 60, and that works out to be 32 over 60, or 16 over 30. So in question 5b, we're given a question and the data is presented in a pie chart. We're told that the number of students who took an exam received grades 1, 2, 3, or 4, and the number of students who actually received a passing grade of 3 was 39 students, and that represented an angle of 117 degrees. So we can write in our pie here that 39 students is represented by 117 degrees. So the first question 1 is how many students took the exam? So we need to determine the total number of students who took the exam. So we know that 39 students represents 117 degrees, and therefore how many students? Let us call this x, represents 306 degrees. That's pretty much the equation we need to form. So we could write simply that x over 39 is equal to 360 over 117. We could form this equation many different ways, but this is just as useful. In this event, we have therefore x is equal to 39 times 360 over 117, and that's equal to 120 students. So we can conclude that the total number of students is 120, and of course that would represent 360 degrees. So that's the first part of our question. So the next part of the question is saying the remaining students, and let us determine quickly what the remaining students are. So remaining students would be total students, 120, minus the students who got a pass at grade 3, 39. So that will be equal to 81 students remaining. So we have 81 students who received passes at grade 1, 2, or 4. And we are told that the ratio of the passing grades between 1, 2, and 4, so for grades 1, 2, and 4, the ratio of the passes is given as 2 to 4 to 3. And this is shared among 81 students. We could then determine that the number of students who got a pass at grade 1 would be equal to 2 over 2 plus 4 plus 3 multiplied by 81, and that would be equal to 18 students who received a pass at grade 1. Similarly, we could write that 4 over 2 plus 4 plus 3 students times 81, which is equal to 36 students received the passing grade at 2. And finally, 3 students over 2 plus 4 plus 3 times 81. That would represent a total of 27 students received a pass at grade 4. So we could enter this information into our table here. So number of students who passed at grade 1 would be equal to 18. Number of students who passed at grade 2 would be equal to 36. The number of students who passed at grade 4 is equal to 27. So if we're told that a passing grade is accepted as a grade 1, 2, or 3, then the total number of students who pass this exam, that is equal to 18 plus 36 plus 39, and that would equal to 93 students. The third part of the question, what is the angle for the grade 1 student? So this is a grade 1 student here. Let's just highlight it here. What is the value of this angle? We know that there are 18 students who pass at grade 1. So what is the angle that should be represented by grade 1? So if we call this angle y, we can say 18 over 120 is equal to y over 360. We could form that equation, and then we'd end up with y is equal to 18 times 360 over 120, and that is equal to 54 degrees. Let's move on to question number 6. So in question 6, we are shown a rectangular tank that holds water. The dimensions of the tank are given, and on the right we're shown a cylindrical vessel that is used to fill the tank. So in the first instance we're shown the tank. The tank is 48 centimeters high, it is 50 centimeters long, 40 centimeters in width. The height of the water currently in the tank is 15 centimeters. So the question is, how much water do we have in the tank? Okay, so let's determine the volume of water in the tank currently. So let's use this here. So here we'll have the tank. So volume of water in the tank is equal to length times width times height. So that would be 50 times 40 times 15. And that's equal to 30,000 cm cube. So now we're told that the cylindrical vessel, which is this one across here, is filled with water, and that water is emptied out into this tank. So what we're asked to find is the new volume of water in the tank. So naturally, the volume of water in the tank would be the volume that is already in the tank plus the new volume that you have just poured in. So let's determine the volume of water that the cylinder can hold. So volume of water in the cylinder, let's write as V is equal to pi r squared h, where pi is taken as 22 over 7, so that's 22 over 7. We're given the radius as 20 centimeters, so that's 20 squared. Times height, which is 21 centimeters, so the volume of the cylinder works out to be 26,400 cm cube. So the total water in the tank now becomes 30,000, and you add 26,400. And that works out to be 56,400 cm cube of water currently in the tank. Part C of the question, what is the new height of water in the tank? Well, the height of water in the tank is now equal to the volume of water in the tank, and that would be divided by the base area of the tank, where the base area of the tank is 40 times 50 or 2,000 cm squared. So the new height of water in tank H is equal to volume of water in the tank, which is 56,400 over 20,000. That works out to be 28.2 centimeters. Part D of the question. So if we want to fill the tank is now 28.2 centimeters and its total height is 48 centimeters. So if we wish to fill the tank completely, how many more cylinders of water do we need to pour into this tank? So to do that, we need to find the remaining volume of water required to fill the tank, or the empty space. So let's just call this remaining volume required is equal to the total volume of the tank, and then you would subtract the volume of water already in the tank. So total volume of tank is equal to 40 times 50 times the total height of the tank, which is 48 cm. That is equal to 96,000 cm cube. But we already have some water in the tank, so we could subtract that. So water in tank currently is equal to 56,400. Remaining volume is equal to 96,000 minus 56,400. and that is equal to 39,600 cm cube. So that is the amount of space we have remaining in the tank. So how many cylinders of volume 26,400 do we need to fill a volume of 39,600? So number of cylinders needed is equal to volume remaining divided by volume of the cylinder. This works out to be 1.5 cylinders. So 1.5 cylinders of water is needed to fill the remaining volume in the tank. Let's move on to the next question. Okay, so question number 7 is a sequences question, and this is where we look for patterns, and we are going to use these patterns to establish some formulas and be able to predict outcomes. So for example, we're given 4 figures on the past paper, and we're asked to draw the 5th figure, which is represented here. So let us go on a search for patterns. So in the first instance, let us call the figure n, and we will look for a relationship between, say, n and the number of dots. Let us look to see if we are seeing that. So when n is equal to 1, the number of dots is 5. When n is equal to 2, number of dots is 9. So already we can see a pattern, because it seems as if we merely need to multiply n by 4 and add 1 to get dots. So that's what it looks like. We could also see that a different way, because between 5 and 9 we have an increase of 4. Notice we're increasing by 4 here. Between 9 and 13 we're also increasing by 4, and we are increasing uniformly by 4. So we can predict that the rate of increase is 4 times n, and in this case we merely need to add 1 to get the number of dots. So we could almost just as easily write an equation relating dots and n. We could write that as d, let's call the dots d, is equal to 4n plus 1. We could see that just by the pattern that we have here. We could also predict easily that since it is increasing uniformly by 4, then the next figure 5 would have 17 plus 4, or 21 dots. If we go over to the circumference column, you can see that the increase first increases by 4 pi, then increases by 6 pi, and this one increases by 8 pi. So the increase is definitely not uniform here, but what we can know that it is changing by 2. So this increased by 2 in the first instance, then it increased by another 2, so we expect that this change would be 10 pi. So this would move to 30 pi. So we can establish that simply by looking at this pattern. So now we need to look for equations for the other columns. So we already have an equation for dots, which is d is equal to 4n plus 1. Let us call the area of the largest circle A, and let us see what we can find based on the pattern. So A is equal to, in terms of n, we notice that when n is equal to 5, A is equal to 25 pi. When n is equal to 4, 16, 3, 9. So we can see a square relationship here just by observation. So we can write A then is equal to n squared pi. Let us look for the relationship for the shaded area, which is this area here. So we are going up by 1, then 3, and 5. So we're going up uniformly by 2. So we know the rate of increase is 2. So we can look for a relationship, and we can recognize that if we multiply, since we know our rate is 2, we know we can multiply n by 2, but then this is not 2 times 5 is equal to 10. So we merely need to subtract 1 to arrive at our area. And we can test this going down. 2 times 4 is equal to 8 minus 1 is 7. 2 times 3 is 6 minus 1 is 5. So we can see our relationship is firm. We could write AS, the area of the shaded portion, is equal to 2 times n, but minus 1. So let us look for a relationship between the circumference C and the figure number n. So this is very important, so pay attention here. If you notice that whereas for the patterns for D, the difference between n and n plus 1 was 4. That was uniform throughout. So we determined immediately that the pattern was going to include the difference as the rate of increase. In the case of circumference, the pattern is such that the difference is not uniform. And when that happens, you need to look at n to see if you can find some help with the relationship. Let me explain what that means by writing. So n is equal to 1, 2, 3, and 4. We notice that the circumference, and let's just leave pi off for a while. So we could write 2, then it goes up to 6, then it goes to 12, and goes to 20. Why am I doing this? Because this difference between one figure and the next is not uniform. So I will need to look in the column n to see if I could get some help with the pattern. So if you notice, what I'm seeing here is that if I multiply n and n plus 1, or the first value of n and the second value of n, so if I multiply across like that, I get this value. If I multiply across like that, I get this value. If I multiply across like that, I get this value. So what it's telling me is that when n is equal to 1, the value I'm going to get is when I multiply n plus 1 to get that value. So in essence, c is equal to n, and I'm going to need to multiply that by n plus 1 to get my value. So let me say this again slowly so you'll understand. Once the difference between the figures is not uniform, try to find some help by looking at n to see if you can establish a pattern using n, instead of simply establishing a pattern using the difference. If the difference is uniform, use the difference to establish your pattern. If the difference is not uniform, use n to establish your pattern. So in this case, I'm just noting that 2 times 1 is equal to 2. So for example, as a predictor, when n is equal to 5, we could say that c is equal to 5 times 5 plus 1 is 6 is equal to 30, which we can show here as being accurate. So this is a very useful thing to recognize. Start by examining the difference between the patterns. If they are uniform, use the rate of increase. If they are not, go into the column n to see if you can get some help. So in this case, we can write then that c is equal to n into n plus 1. That is the pattern for c. So now that we have the pattern or the equation for all the columns, we can fill in the table quite easily. So when d is equal to 541, we can write that the equation d is equal to 4n plus 1. So if that is equal to 541, and we have this equation, we can write that 4n is equal to 541 minus 1, which is 542. Therefore, n is equal to 540 over 4, that is equal to 135. So n is equal to 135. Part C is asking us to determine the area of the largest circle, given that n is equal to 3p. So we know that the area of the largest circle, the formula is a is equal to n squared pi. So if n is equal to 3p, then that's 3p all squared times pi, which is equal to 9p squared pi. So we could write that in here. So that takes us to the end of question number 7. Let's move on to question number 8. So in question number 8, we are given an equation x is equal to 5 minus 3y. We're asked to determine where this equation cuts the two axes, the x and y axes. So in essence, we're asked to determine the value of y when x is equal to 0 and the value of x when y is equal to 0. That's what we were asked to find. So we could just simply stick these values into the equation. So if x is equal to 0, then 0 is equal to 5 minus 3y. Therefore, 5 is equal to 3y, giving y is equal to 5 over 3. And in the other instance, we're asked to determine the value of x when y is equal to 0. And we can see straight from here that if y is equal to 0, then x is equal to 5 minus 3 times 0. Therefore, x is equal to 5. In essence, I could make a simple sketch here on the side. So 0, 5 over 3. So x is 0, y is equal to 5 over 3. That's one point. And the other point is 5 and 0. So this point is 5. So this would be our line. So if we're given that the point P is where it intersects the y-axis, we could write as P. Coordinates are 0, and 5 over 3, and the coordinates of Q, 5, 0. So in part 2 of this question, we are asked to determine the length of this line. And of course, we could use Pythagoras to help us with this. So, for example, the length of the line, we could call this one L. That's equal to the square root of 5 over 3 all squared plus 5 squared. That works out to be 5.27 units. So if we denote that R is the midpoint of this line, if the coordinates of R are, say, xm and ym, where xm refers to the midpoint coordinate x, which is here, and ym refers to the midpoint coordinates ym, then we could write that xm is equal to 0 plus 5 over 2, which is equal to 2.5, and ym is equal to 0 plus 5 over 3, half of that, to be equal to 5 over 6. Part 8b of this question. So whenever we're given a function in the form of a mapping equation, f colon x maps to 5 minus x, this is the same as this. So it's just two different forms of representation. So this is merely saying that function of x is equal to 5 minus x, which I've written here. So we're given two functions, f of x is equal to 5 minus x, and g of x is equal to x squared minus 2x minus 1, and we're to find the point of intersection. Whenever two functions meet at a point, which is the point of intersection, that point is found by equating these two functions. So in essence, what you'll be having is let f of x be equal to g of x, and that would represent where the functions meet. So if we equate these two functions, we will have 5 minus x is equal to x squared minus 2x minus 1. And we can simplify this as x squared minus 2x minus 1 minus 5 plus x, that's equal to 0. So we simplify further, and we have x squared, and we have minus 2x and 1 positive x, so we have negative x, negative 6 is equal to 0. And this is a simple factorization problem where we can use two brackets to get the factors, because this will be x minus 3 and x plus 2 is equal to 0. So we can say that either x minus 3 is equal to 0 or x plus 2 is equal to 0, in which event x is equal to 3 or negative 2. So now that we have our two values of x, we can determine the values of y. So using any one of the equations, let's choose the simpler one. So given that f of x, which is equal to y, is equal to 5 minus x, we can say that when x is equal to 3, we can write y is equal to 5 minus 3 equal to 2. So if we call this first intersecting point M, then the coordinates are x is equal to 3 and y is equal to 2. The second intersecting point, if we call this one M, let's determine what the value of y is. So if x is equal to negative 2, so when x is equal to negative 2, we have y is equal to 5 minus negative 2, which is equal to 7. Therefore, the second intersecting point N occurs at x is equal to negative 2 and 7. So these are the two intersecting points. In question 8b, a cyclist traveling at 12 meters per second after 4.5 seconds decides to decelerate uniformly to 0 meters per second in an additional 2.5 seconds. So we can find his deceleration simply by recognizing that deceleration is equal to his final speed, which is 0, minus initial speed, which is 12 meters per second, divided by the time in which this happens. So he's traveling at v1 here, and his final speed here at v2 is 0, and he does that in a time of 2.5 seconds. So the time in which he decelerates from his initial speed to his final speed is 2.5 seconds. So we divide by 2.5 here, and that's equal to negative 4.8 meters per second squared. Part 2 of the question is to find the average speed. So the average speed is given as total distance over total time, where the total distance is given as the area under the graph. So if you look at the area on this graph, you'll notice it is divided into two parts. This is the first part here. I'll call this one A1, and that's the area of this rectangle. And then over here we have A2, that's the area of this triangle. So let's find, so distance is equal to area 1 plus area 2. So let's find area 1, that's the area of the rectangle. It's just simply length by width, which is 12 times 4.5. That's equal to 54 meters. A2, the area of the triangle, is equal to half base times height, which is half of the base, which is 2.5 times the height, which is 12, and that is equal to 15 meters. So area 1 plus area 2, which is equal to the distance, is equal to 69 meters. And of course, the total time taken is equal to 7 seconds. So average speed is equal to 69 over 7, which is equal to 9.86 meters per second. So for 9a, we're looking at a problem in circle geometry. So what we're seeing here is we need to find three angles. The first angle is angle BAC, which is this angle here, described as 2P. We're also asked to find angle Q and angle R. So this is angle Q, this is angle R. So let us start by finding them in order. So we'll find BAC first. Now in order to find BAC, we need to recognize that since O is the center of the circle, then AC is the diameter of that circle, and any angle subtended from the diameter at the circumference, for example B, will be 90 degrees. So we could put B here as 90 degrees. Let's label that 90 degrees. Now that we know that this is 90 degrees, from triangle ABC, where angles in a triangle are 90 degrees, then it means 2P plus 3P must also add to 90 degrees. So let's write that down. So we could have 2P plus 3P is equal to 90 degrees. Therefore, 5P is equal to 90 degrees, giving P is equal to 90 over 5, or 18 degrees. So therefore, 2P is equal to 36 degrees. Let's put that in. So that's your angle BAC. Let's just confirm that this is actually angle BAC. The next angle we need to find is angle Q, which is this angle down here. Now, if you notice that angle Q and angle 2P are the same angles because angles in the same segment are equal. Notice that from chord BC, we have an angle in this segment, BAC, and therefore we can say that BAC is equal to BDC because angles in the same segment are equal. Therefore, Q, which is equal to BDC, is equal to 36 degrees. Let's put that in. Now, consider triangle ODC, and we know that triangle ODC is isosceles. Therefore, the base angles are equal. So angle Q is equal to angle R. Result, R is equal to Q, which is equal to 36 degrees. So in question 9b, we have a bearings question. And here we're given two bearings. First, the bearing Q from H. What does that mean? It means I am at H and I want to get to Q, and I'm also given the bearing S from H. So what would be my bearing? Let us just remind ourselves that a bearing is simply an angle. So we have 3 points H, Q, and S. And in the first instance, let us identify the bearing Q from H, which is 311 degrees. So let's write that here. So it's measured from north in a clockwise direction all the way to S. That's our bearing identified there in blue. And next we identify the bearing S from H, which is 185 degrees. So we move all the way from north again in a clockwise direction, and we end up here touching the line going from H to S. So these are the bearings that we are given in the first instance. So the question is asking us to find this angle, which I'm going to denote here as X. Now notice that X is simply the bearing 311 minus the bearing 185. So let's just write. So we have X then is equal to the bearing 311 degrees minus the bearing 185 degrees, giving us 126 degrees as our angle X. So now that we have our angle X, let's just write it in. X is equal to 126 degrees. So note that our next task is to find the length QS. So if we call this side H, then we note that we have two sides and we have the included angle. So we know we should apply our cosine rule. Whenever we have two known sides and the angle between those two sides, we can apply the cosine rule. So we could write that H, just write H squared is equal to the square of the sides, which is 5.4 squared plus 3.5 squared minus 2 times 5.4 times 3.5 multiplied by the cosine of 126 degrees. So H squared is equal to 63.67 kilometers, and H is then the square root of 63.67, which is equal to 7.97 kilometers. So let's just put that in here. H is equal to 7.97 kilometers. Okay, so now that we have H, our final task is to find the bearing S from Q. So if we are going from Q, it means we are at Q and we need to get to S. So let's identify that bearing here. So this is the bearing measured from north until we hit the line going from Q to S. So that bearing is clearly made up of three parts. Let's just identify them here. The first part is 90 degrees between north and east. Then we have this angle, which I'm going to note here as Z. And then we have this angle, which is one angle of triangle SQH. Let's call this angle K. So if we call this angle Y, then we can say that the bearing S from Q is equal to Y plus Z plus K. We will find these angles and we will find our bearing. So we already know that Y is equal to 90 degrees. So let's just put that in. So we already have 90 degrees. So let's go ahead to find angle Z. Now angle Z, if you note, is actually one angle in a right angle triangle. Let's identify the triangle. If I were to project this line going from the east all the way out until it meets this line from the north going up, then this would be a right angle, 90 degrees. Therefore, we know that this angle, which I can call P plus Z, is equal to 90 degrees because this angle is 90, so these two should also add to 90. So I can write that P plus Z is equal to 90 degrees. Do I know the angle P? Well, indirectly I do, because P can be found by recognizing that the bearing Q from H is 311. This almost completes the 360 degree. So angle P is the remainder of that angle. So we can say that angle P is equal to 360 degrees minus 311 degrees, and that is equal to 49 degrees. So we could put that in here. So now that we know P to be 49 degrees, we know that Z must be equal to 90 degrees minus 49 degrees, which is equal to 41 degrees. So we could sit that in as well. So now that we know that angle, we have completed finding two of the angles. Let's just put that in. So we have one more angle to find, and that's angle K. So So how do we find angle K? Well, we note that we have an angle and a side opposite that angle. We also have a side opposite the angle K, which is unknown angle, so we can apply the sine rule. We have two sides and a non-included angle, so we could use the sine rule. So let's set up the sine rule formula, which is sine of K over 3.5 is equal to the sine of 126 degrees over the opposite side, which is 7.97. We found that earlier. So we could write that the sine of K is equal to 3.5 multiplied by the sine of 126 degrees over 7.97. And this works out to be 0.3549. So therefore, K, the angle, must be the inverse sine of 0.3549. And that works out to be 20.8 degrees. So we have our last angle as K is equal to 20.8 degrees. We could add that here. So finally, we have 20.8 degrees, and we add all of these together to get the bearing S from Q is equal to 151.8 degrees. So that's the bearing S from Q. So here we have a matrix W given as 3, 6, negative 2, 5, and we're asked to find a matrix L such that W plus L is equal to 0, 0, 0, 0. So this means that we could rewrite our matrix W, 3, 6, negative 2, and 5, and we need to add this to a matrix L, where L plus W must give us the matrix 0, 0, 0, 0. So we can see clearly that 3, and this needs to be a minus 3 to give me a 0 here. Therefore, I just need to reverse the sign of each of these elements in the matrix W to find the matrix L. So this works out to be negative 6, 2, and negative 5. When we sum those together, we get the matrix 0, 0, 0, and 0. Next, we are asked to find a matrix P such that W times P is equal to the identity matrix 1, 0, 0, 1. Now we know that when you multiply a matrix by its inverse, the result is the identity matrix. So W multiplied by its inverse, that's W inverse, will give you the identity matrix 1, 0, 0, 1. Therefore, P must be equal to the inverse of the matrix W, and that is equal to the adjoint of W over the determinant of W, where we know that the adjoint of W is equal to, and this is how we find this one. What we do is we reverse, or we switch around the two leading diagonal elements. So 3 and 5 will be switched around. So let's do it one at a time. So we'll put 5 here and 3 here. We've switched around these two elements. These are the leading diagonal elements. These are the non-leading diagonal elements, 6 and negative 2. We need to reverse the sign of the non-leading diagonal elements. So this will become negative 6. This will become positive 2. And that's the adjoint matrix. The determinant W is simply equal to 3 times 5 minus 6 times negative 2. Let's write that down. So it's 3 times 5. And we're going to subtract 6 times negative 2. So that's equal to 15 plus 12. That's equal to 27. Therefore, inverse of W, which is equal to P, the matrix we're trying to find, is equal to 5, negative 6, 2, 3 over the determinant 27. So that's our answer. Let's move on to the next part of this question. So in part B, we're given a triangle M whose vertices X, Y, and Z are shown. And we are told that this triangle will be transformed by a matrix N, and we're asked to find the image coordinates X prime, Y prime, and Z prime. So first, let's write the matrix equation, which would be M prime will be equal to n multiplied by m, where m prime is the image triangle and m is the object triangle. So we'll have that is equal to n, which is 0, 1, 1, 0, and we'll multiply that by m, and we'll write this as a matrix. So that's m, and this is x, that's 1, 1, y is 3, 1, z as 3, 4. So these are the two matrices that we're going to be multiplying together, and the answer works out to be 1, 1, 4, 1, 3, 3. That's for matrix m prime, and the image coordinates are x prime, y prime, z prime. So we could write as x prime is 1, 1, y prime is 1, 3, and z prime as 4, 3. Question 10c shows a triangle OPQ. This is a vectors problem, and we're given that the vector from O to L is equal to 2u. So let's note that now. So it's O to L is equal to 2u, and L to P is equal to u. At once we can see then that the vector O to P is equal to 2u plus u, or we could write as O to P is equal to 2u plus u, and that is equal to 3u. So let's make a note of that. So the vector O to P is equal to 3u. We're also told that M is the midpoint of PQ. So let's make a note of that. So M is midpoint PQ, and also that Q is midpoint of OR. So what we can deduce immediately is that if M is midpoint of PQ, then PM is a half of the vector PQ. So let's write the vector P to M will be a half of the vector PQ. We can deduce similarly that if OQ is equal to QR, because Q is the midpoint, then if OQ is equal to V, then QR is also equal to V. So we could just insert that here. Vector QR is equal to V. Our first task is to find the vector LM. So we can see that the vector going from L to M, so you imagine that you're at L and you want to get to M. So you can go from L to P in this direction, and then from P to M in that direction. So we can write that the vector L to M is equal to L to P plus P to M. Now we already know that the vector L to P is equal to U, so we could stick that in, plus PM. So we wish to find the vector PM, so let's write P to M. We know to be equal to a half the vector P to Q. So we now need to find the vector PQ. We should note that the vector PQ is a vector going from P to O and then from O to Q. So it's going in this direction from P to O and then from O to Q in this direction. So let's write P to Q is the vector going from P to O plus the vector going from O to Q. Now we note that the vector P to O is the inverse of the vector O to P, and we have that vector, we found it here earlier, O to P is equal to 3u. So we could write is the inverse vector O to P plus O to Q. We could rearrange and write as O to Q minus the vector O to P. And we do have vectors because OQ is the vector going from O to Q, which is V, and O to P is the vector 3u. So it's V minus 3u. That's your vector PQ. So let's write this here. PQ is equal to V minus 3u. But this is just going to help us to find the vector PM. So we can write then that PM, which is what we're after, is equal to a half of this vector PQ, which is V minus 3u. So we can now establish the vector LM. So we write, so finally LM, the vector LM is equal to U plus PM, which we have just found, which is a half of v minus 3u. So let's simplify. So that's equal to u plus, and we expand, there's v over 2 minus 3u over 2. So we find our LCM and we convert u to 2u over 2. And this is just to get the denominators of all terms to be equal to 2. So it's 2u over 2 plus v over 2 minus 3u over 2. So negative 3u plus 2u is going to give me negative 1u over 2. So the answer is v over 2 minus u over 2. And we can rewrite this as a half of v minus u. That is our vector equation for Lm. So let's write that down. So Lm is equal to a half of v minus u. So that takes care of our first question. The next question is to find the vector PR, and that's the vector going from P to R. So let's identify the vector first, which is the line connecting the 2 points. So let's draw. So that's our vector going from P to R, and it's going in the direction of P to R. So let's label our vector. So at once we can see that the vector going from P to R is the equivalent of the vector going from P to O and from O to R. So let's just write vectorially. Vector P to R is equal to P to O plus the vector going from O to R. Do we have vectors for these? Yes, we do. The vector P to O is negative 3u. We've determined this earlier. Plus O to R. O to R is v plus another v, so it's 2v. So PR works out to be 2v minus 3u. So let's stick that in here as another term that we just found. So we have the vector PR, let's write it here, is equal to 2v minus 3u. We will need this result later, so let's leave it there for now. Finally, we're asked to show that the points L, M, and R are on a straight line, or simply put, they are collinear. So for points to be collinear, they need to satisfy two conditions. First condition, the vectors connecting the points must be parallel. Second condition, the vectors must share at least one common point. Now we have a total of 3 video lessons on vectors, so if you're having some difficulty following us here, please take a look at those lessons before you continue. So these are the 2 conditions that must be satisfied to prove that the points L, M, and R are collinear. The vectors connecting the points must be parallel. This means that vector Lm must be parallel to, say, vector Lr. So we can find the vector from L to R, and then compare that with the vector Lm to see if they are parallel. What is the proof that 2 vectors are parallel? In this case, the proof would be that the vector L to R is equal to a scalar multiple of the vector L to M. This is a single requirement that is needed to prove that these 2 vectors are parallel. Lr is simply a scalar multiple Lm. We already found the vector Lm, so what we need now to do is find the vector Lr. So let's proceed to do that. So once again, just to remind everyone what it is that we're doing now, we are trying to show that points L, M, and R are collinear. And in order to do this, we need to show that the vectors are parallel. The 2 vectors that we're comparing are the vectors Lm and the vector Lr. So we will compare these 2 vectors to see if they're parallel and also to see if they share a common point. Well, it is obvious that the vector Lm and Lr share a common point because that point would be L. So we have already satisfied condition number 2. So now we need only to show that Lm and Lr are parallel. To do this, we need to show that Lr, the vector, is a scalar multiple or a constant multiplied by the vector Lm. We already found the vector Lm. We found that Lm is equal to half v minus u. So let's proceed to find the vector Lr. The vector going from L to R is the vector that goes from L to P in this direction, and then the vector going from P to R in that direction. So let us write vectorially. LR is equal to L to P plus P to R. There are two vectors that we are summing, and the vector L to P we note to be equal to U, and the vector P to R. So let us determine the vector P to R. Do we have that vector? Yes, we do. We determined it earlier. Here it is. PR is equal to 2B minus 3U. So that's right. 2B minus 3U. So simplifying, we have U minus 3U is equal to negative 2U. So we have LR is equal to 2V minus 2U, which can be factored as 2 into V minus U. So we have the vector LM, and now we have the vector LR. Now let us compare these two vectors. Note that LR, the vector, is equal to 2 into V minus U. And we're going to perform a little trick here, which is to simply recognize that we could write 2 as being equal to 4 times a half. 4 times a half is equal to 2. And I'm doing this for a reason. So let's just be clear that I'm just simply changing this into this for a reason. Let's establish that reason now. So we can rewrite LR then, the vector LR, as 4 times a half into V minus U, which is the same as 2 into V minus U. I have mathematically these two are the same. These two are the same mathematically. But what is now interesting is that this portion is the same as LM. So this is LM, the vector LM. So LR is simply 4 times the vector LM. And that is the necessary and sufficient condition for my proof that the two vectors are related by a constant. And so these two vectors are parallel, so we can conclude that points L, M, and R are collinear. So this is the final question on the January 2021 paper. See you soon.